Every can of Sting begins with something simple: water. But inside a modern factory, that water starts a carefully controlled transformation into energy. From the outside, a Sting can looks simple, bright, red, and familiar. But behind it is a long industrial journey few people ever see. The first stage is not mixing, filling, or packaging. It is choosing water clean enough to become the foundation of the drink. This water may come from underground wells or municipal supplies, but once it enters the factory, it must meet strict internal standards. Before anything else happens, technicians test the incoming water for clarity, mineral content, odor, and possible impurities that could affect production. If the water fails quality checks, it cannot move forward. Every drop must be reliable before becoming part of an energy drink. The accepted water enters the filtration system, where large particles like sand, dust, rust, and sediment are removed from the flow. Filtration is the first physical barrier, protecting the entire process from unwanted particles that could damage equipment or affect final taste. After the first filtration stage, the water moves into activated carbon treatment, where odor, chlorine, and organic compounds are reduced. Activated carbon works like a powerful sponge, trapping substances that could make the drink smell strange or taste unpleasant. Now the water is clearer, but the factory still needs deeper purification to make the base stable and predictable for every batch. The next step is reverse osmosis, one of the most important purification technologies used in high-volume beverage production. Under high pressure, water is pushed through extremely fine membranes that separate pure water molecules from dissolved minerals and microscopic contaminants. This process produces an ultra-clean liquid base, nearly free from impurities, allowing the flavor formula to remain consistent every time. But completely purified water can taste flat, so the factory carefully adjusts minerals to build the correct foundation for the drink. This mineral balancing step helps create a stable mouthfeel, ensuring the final Sting taste does not change from one batch to another. Once the water base is approved, it is transferred through sealed pipes into the ingredient preparation zone, where the real transformation begins. Inside this area, every ingredient is measured carefully, because energy drinks depend on exact formulas, not guesswork or random mixing. Sugar or sweeteners are prepared first, giving the drink its recognizable sweetness and helping create the quick energy impression consumers expect. The amount of sweetness must be exact because too much can overpower the flavor, while too little can make the drink feel weak. Next comes caffeine, one of the most important ingredients, added in carefully controlled quantities to support alertness and stimulation. Caffeine cannot be added casually. In professional factories, dosing systems control every gram to meet safety and product requirements. Taurine is then introduced, a common energy drink ingredient associated with focus, endurance, and the identity of modern energy beverages. Acids such as citric acid are added to balance the sweetness and create a bright, sharp, refreshing flavor on the tongue. Flavor compounds are prepared separately, because the signature taste of Sting depends on a carefully protected blend of fruit-like notes. Color is also controlled carefully, helping create the bold visual identity that makes the drink recognizable before the first sip. All ingredients now wait for one critical moment: the mixing stage, where water becomes the flavored energy drink base. Purified water is pumped first into massive stainless steel tanks designed to hold thousands of liters under hygienic factory conditions. Then, the syrup base enters the tank, bringing sweetness, color, and early flavor into the once clear purified water. Powerful mixers begin spinning, pulling the syrup through the water until the entire tank becomes uniform in color and composition. The caffeine, taurine, acids, and flavor compounds are introduced gradually, allowing the mixture to absorb each component evenly. Nothing is rushed here. Even in a fast factory, mixing requires controlled timing to prevent clumping, separation, or uneven taste. Sensors inside the tank measure temperature, density, and flow speed, giving operators real-time information about the developing drink base. At this point, the liquid has changed completely, from neutral purified water into a bright, sweet, energetic formula. But before it can continue, the mixture must pass laboratory testing to confirm that every chemical parameter is within specification. Technicians check sugar concentration, acidity, caffeine level, color, strength, and aroma, comparing each sample with approved factory standards. If the sweetness is slightly low, the formula may be adjusted. If caffeine is outside limits, the batch cannot continue. This constant testing is what keeps every can tasting almost identical, whether produced today, tomorrow, or months later. Once the formula is approved, it moves through sealed pipelines toward carbonation, where the drink receives its sparkling character. Carbonation begins when carbon dioxide is injected into the liquid under pressure, dissolving gas into the drink base. These bubbles are not only visual, they affect mouthfeel, freshness, flavor perception, and the exciting sensation when the can opens. Too little carbonation makes the drink feel flat, while too much pressure can create problems during filling and sealing. The factory must find the exact balance, so the drink stays fizzy, stable, and safe inside the sealed aluminum can. While the drink is being carbonated, another production line is preparing the container that will protect it, the aluminum can. It starts with flat aluminum sheets, thin but strong enough to be shaped into lightweight cans at incredible speed. High-speed presses punch circular blanks from the aluminum, creating the first rough shape that will later become the can body. These blanks are drawn and stretched into tall cylinders, transforming flat metal into recognizable can shapes within seconds. Every can must have the correct height, wall thickness, and strength, because it must survive pressure, transport, and handling. After forming, the rough edges are trimmed so the can becomes smooth, uniform, and ready for cleaning and decoration. Before printing or filling, the cans are washed thoroughly to remove oil, metal dust, and any residue from the forming process. Clean cans then pass through drying systems, where hot air removes moisture and prepares the surface for printing. The outside of each can is printed with bold graphics, giving it the bright red identity consumers recognize instantly. This printing must be perfectly aligned, because a crooked logo or faded color can make the product look defective. After printing, a protective coating is applied to help the can resist scratching, moisture, and damage during distribution. Inside the can, a food-safe liner protects the drink from direct contact with aluminum and helps preserve its intended flavor. The printed cans are now empty, clean, and ready, moving on conveyors toward the filling area at high speed. Before filling, air inside each can may be controlled to reduce oxygen exposure and help protect the drink's freshness. Oxygen is the enemy of flavor stability, so modern filling systems are designed to reduce unnecessary contact with air. Now the carbonated sting liquid arrives from sealed tanks, cold, pressurized, and ready for precise high-speed filling. The filling machine moves with incredible speed, placing each can under a nozzle for only a fraction of a second. Every can receives the same volume, because underfilling disappoints customers, while overfilling creates pressure and packaging problems. The process happens in a controlled environment, where hygiene, pressure, temperature, and timing are all carefully managed together. After filling, the can immediately receives its lid, because the carbonated drink must be sealed quickly to retain pressure. A seaming machine folds the lid and can body together, creating an airtight seal strong enough to hold carbonation inside. This seal is critical. If it is weak, gas can escape, liquid can leak, or contamination can enter the product. After sealing, each can is rinsed from the outside to remove any sticky liquid left during the high-speed filling process. The cans then move toward pasteurization or thermal treatment, depending on the factory process and product stability requirements. Heat treatment helps reduce microbial risk, protecting the drink and extending shelf life before it reaches stores and consumers. The temperature must be controlled carefully, because too much heat can damage flavor, while too little may not provide enough protection. After heating, the cans pass into cooling sections, where water sprays gradually bring the product back to a stable temperature. Cooling must be gradual, preventing stress on the can and helping maintain the pressure balance inside the sealed container. Once cooled, the cans are dried again, because moisture on the surface can interfere with labeling, packing, or carton strength. The finished cans now look ready, but they still face some of the strictest inspections in the entire production line. High-speed cameras inspect each can for dents, scratches, printing errors, wrong fill level, and possible sealing defects. Any can that fails inspection is rejected automatically, pushed off the line before it can reach packaging or distribution. Random samples are also opened and tested by quality teams, confirming taste, aroma, carbonation pressure, and chemical composition. This human testing matters because machines can measure numbers, but trained experts can detect subtle changes in flavor experience. If the sample tastes different from the approved profile, the team investigates the batch before allowing it to leave the factory. Once the batch passes every inspection, the cans are cleared for packaging, entering the final stage inside the factory. Packaging begins by grouping cans into smaller sets, such as 6-packs, 12-packs, or retail trays for easier handling. The cans are arranged with precision, so each pack looks neat, stable, and ready for transport without shifting or damage. Plastic wrap or cardboard sleeves may be applied, holding the cans together and protecting them during shipping and shelf display. Printed cartons are also used, carrying product information, barcodes, batch numbers, and branding for stores and warehouses. Every package receives traceability codes, allowing the company to identify when, where, and how each batch was produced. Traceability is important because if a problem appears later, the factory can track the exact production line and time window. The packed products are weighed and scanned to confirm that each carton contains the correct number of cans. If a carton is too light or too heavy, it may indicate a missing can, extra item, or packing mistake. Approved cartons move to palletizing, where robots stack them in stable patterns for warehouse storage and truck loading. The stacking pattern is carefully designed because unstable pallets can collapse during movement, damaging hundreds of cans at once. Once stacked, the pallet is wrapped tightly in plastic film, locking the cartons together for safe transportation. Forklifts then move the pallets into storage zones, where finished products wait before being shipped to distribution centers. Warehouse teams manage inventory carefully, making sure older batches leave first while newer batches remain organized behind them. This system helps maintain freshness and prevents products from sitting too long before reaching shops and consumers. When an order arrives, pallets are selected, scanned, and prepared for loading onto trucks heading toward regional distributors. Loading must be organized carefully, because beverage cartons are heavy, and poor stacking can damage cans during long transport. Trucks carry the finished cans away from the factory, turning a controlled manufacturing process into a nationwide distribution journey. From this point, logistics takes over, connecting factories, warehouses, supermarkets, convenience stores, and small shops across the region. Distribution centers receive the pallets, check documentation, scan product codes, and organize shipments for smaller local deliveries. Some cans go to large supermarket chains, while others are sent to gas stations, vending suppliers, and neighborhood stores. In every location, the goal is the same: deliver a can that looks good, tastes fresh, and remains safe to drink. Before the customer ever opens it, the can may sit in storage, travel in trucks, and wait on a retail shelf. That is why the aluminum can, internal liner, sealed lid, and packaging all work together to protect the drink. When the can reaches a store, workers unload it, scan it, and place it where customers can easily see it. Refrigeration changes the consumer experience, because a cold, carbonated energy drink feels sharper, fresher, and more refreshing. The red color, bold design, and familiar shape are all meant to stand out quickly in a crowded drink section. A customer reaches for the can, not seeing the filtration systems, mixing tanks, laboratories, and machines behind that simple choice. The moment the tab is lifted, pressure releases, creating the familiar sharp sound that signals carbonation escaping from the can. That sound is the final proof of a long chain of controlled pressure, sealing precision, and carbonation management. When poured into a glass, the drink reveals its bright color, active bubbles, and the engineered balance of sweetness and acidity. The first sip feels simple to the consumer, but it represents water science, ingredient chemistry, machine precision, and quality control. From the factory's perspective, the goal is not just taste. It is repeatability across thousands or millions of cans. Every ingredient, every temperature, every pressure reading, and every inspection exists to make one can match the next. This is why modern beverage production depends on automation, because human hands alone could never maintain such speed and consistency. But humans still matter, because engineers, technicians, lab teams, and warehouse workers guide the process at every critical point. The journey of a Sting can is a partnership between nature's simplest liquid and one of the most optimized industrial systems. It begins with water. But water alone is not enough. It needs purification, balance, formula, pressure, and protection. Each stage adds something important, either removing impurities, building flavor, preserving freshness, or preparing the product for transport. The water treatment stage removes uncertainty, creating a clean base that gives the factory full control over the final drink. The ingredient stage adds identity, turning neutral liquid into a recognizable energy drink with sweetness, stimulation, acidity, and aroma. The mixing stage creates unity, ensuring every part of the tank carries the same flavor, color, and active ingredients. The carbonation stage adds excitement, filling the drink with bubbles that create texture, sound, and a refreshing drinking sensation. The can-making stage creates protection, using thin aluminum shaped into a strong container that can hold pressure safely. The filling stage connects formula and package, placing the drink into the can at high speed without losing control. The sealing stage locks everything inside, preserving carbonation, preventing leakage, and protecting the drink from outside contamination. The inspection stage protects the consumer, removing cans with defects before they can ever leave the controlled factory environment. The packaging stage prepares the product for the real world, where it must survive stacking, storage, transport, and retail handling. The logistics stage carries the drink beyond the factory, turning production output into something available in everyday shops. By the time the can reaches the shelf, every visible detail has already passed through dozens of invisible controls. The customer sees only the final product, but the factory sees a sequence of decisions, measurements, corrections, and approvals. That is the hidden story behind a simple energy drink can. Industrial precision wrapped in a bright, familiar package. From water purification to ingredient dosing, The factory removes randomness and replaces it with repeatable, measurable control. From carbonation to sealing, the factory protects the sensory experience consumers expect when they open the can. From inspection to packaging, the factory protects quality long after the drink leaves the production line. From warehouse to store, the supply chain protects availability, making sure the drink appears where consumers expect to find it. The entire process is fast, but behind the speed is discipline, because one weak step can affect the entire batch. A wrong mineral balance can change taste. A weak seam can lose pressure. A damaged carton can ruin transport. That is why every department, from water treatment to shipping, becomes part of one connected system. The journey may look mechanical, but its purpose is human, delivering a drink that feels consistent, refreshing, and energizing. When you hold the can, you are holding purified water, chemistry, engineering, packaging, science, and logistics in one object. The can feels small, but the system behind it is massive, involving machines, people, standards, laboratories, and transportation networks. This is the complete journey. Water enters the factory, becomes formula, gains bubbles, enters cans, and moves into the world. Every step has a reason, and every reason connects to safety, taste, freshness, appearance, or consumer trust. Without purification, the taste would be unstable. Without testing, mistakes could spread. Without packaging, the product could fail. Without logistics, even the best drink would never reach the cold shelf where customers make their final decision. So the next time a can opens with that sharp sound, remember the long chain that made it possible. That sound began far earlier. Inside water filters, mixing tanks, carbonation systems, seaming machines, and quality control laboratories. The first sip may last only seconds, but the process behind it requires planning, precision, and constant supervision. A Sting can is not just a drink. It is a carefully built product shaped by science and industrial discipline. From water to energy, from factory to shelf, every can carries a hidden journey most people never think about. So when you open the next can, remember, you are not just drinking energy. You are tasting an entire modern production system.